Hello, and welcome to this video on trigonometric substitution. We're going to use a trigonometric substitution to find this definite integral. We have the integral between -2 and 0 of the function x over the square root of 5 minus 4x minus x squared. The first thing we want to do is we wanted to take the quantity under the root, and we want to write it as a squared minus x squared, probably with a different x. So let's see, 5 minus 4x minus x squared will be written as something like a squared minus another x squared. So let's write just u squared so that we get the root of something that we have worked with in the past. And if you haven't seen how to work with those, please check another video. I have various videos of trigonometric integrals. Just check one in which we see a squared minus x squared under the root. Here to write 5 minus 4x minus x squared as a number squared minus a variable squared, we complete squares. So we say, okay, this is 5, take away, and we can write 4x plus x squared inside parentheses. And 4x plus x squared is the first terms that come from expanding x plus 2 squared. We have the square of the first one plus twice x times 2, that's 4x. But we don't have that third term that comes from expanding x plus 2 squared, so we subtract it. So here we have 5 minus, then x plus 2 squared minus times minus gives us plus 4. So there is 9 minus x plus 2 squared. And here is our a squared minus u squared, where a is 9 under the root, so that's 3. Let's take the positive root, and u is x plus 2. So the first thing we're going to do is we're going to apply a substitution. We have that the integral of -2 to 0 of x dx is the same over 5 minus 4x plus x squared under the root is the same as the integral from -2 to 0 of x dx over, and here we completed the squares to get this equivalent version of the expression under the root. We have something like this, and this is when we use the substitution, u equals x plus 2, so du is the same as dx, and x is u minus 2. We get the integral from, and when x equals -2, u is equal to -2 plus 2, and that's 0. When x is 0, then u is equal to 2. We go from 0 to 2 of x, and x is u minus 2, divided by the square root of 9 minus u squared under the root, and then dx is du, so we have du. Okay, so the first step we took in order to find the integral we were given is we took the substitution u equals x plus 2, so that we look at the integral from 0 to 2 of u minus 2 divided by 9 minus u squared du. Okay, so we have the integral from 0 to 2 of u minus 2 divided by the square root of 9 minus u squared under the root, and then du. To work with this integral, we use trigonometric substitution. because we have the root of a squared minus something squared, it makes sense to use a substitution. U equals square root of 9, so that's 3 times the sine of theta. That way, 9 minus u squared under the root becomes 9 minus 9 sine squared of theta. That's 9 multiplied by 1 minus sine of theta, that is squared. We have 9 times the cosine squared of theta by the fundamental trigonometric identity. So this is 3 times cosine of theta when we work with theta between certain values, and we're not going to worry about that at the moment. We're just going to assume that we have 3 cosine of theta when we take that root. And then du is equal to 3 times cosine of theta d theta. We're working with an integral in terms of theta. And in terms of theta, we are working with u, that's 3 sine of theta minus 2 divided by 3 times cosine of theta. And then du is 3 times cosine of theta d theta. Now as for the bounds, when u is equal to 0, we're saying that 3 times sine of theta is 0. So sine of theta is 0. So theta is an odd multiple of pi, and we're going to take the smallest multiple possible, that's greater than or equal to 0. We're not going to worry so much about why we're taking 0 instead of, say, pi or 2 pi or any other number like that. We just take the arc sine of 0, and that's going to be 0. And then for u equals 2, we're saying that 3 sine of theta is 2. So that sine of theta is 2/3. Then we can say that theta is the arc sine of 2/3, probably plus a multiple of 2 pi, but we're not going to worry about that. Okay. So the bounds are 0 to arc sine of 2/3. So we have the integral that we were given. And that was the integral from minus 2 to 0 of x dx over 5 minus 4x plus x squared, or better, minus x squared. That equals the integral from 0 to arc sine of 2/3. Then 3 cosine of theta divided by 3 cosine of theta gives us 1. We have 3 times sine of theta minus 2, and then d theta. And we can use the fundamental theorem of calculus to say that this integral we just got is minus 3 times the cosine of theta minus 2 times theta evaluated at arc sine of 2/3 and at 0. And when we substitute arc sine of 2/3 into theta, in the expression we have minus 3 cosine of theta minus twice theta, we get the expression minus root of 5 plus 2 times arc sine of 2/3, and then plus 3. So that comes from the evaluation. All right. here we have solved a problem by using two substitutions. One of them is a regular substitution. The other one is a trigonometric substitution. In general, we may have to combine some approaches in order to solve problems. So the first thing we did was we completed squares and realized that we had a shifting x plus 2. So we used u equals x plus 2 first. And then once we got the root of 9 minus u squared on the bottom, we realized that we needed to use a trigonometric substitution. So we used u equals 3 sine of theta. All right. If you have any questions, let me know. Please write comments, and I will try to reply as soon as possible. Thank you for watching. Bye-bye.